So today we are going to talk about an AI video about lip sync expert in generation Y. So as the thumbnail speaks, we you have seen in movie pictures are speaking up, people in videos are speaking in some other language. So we are going to discuss about that. Published in ACM Multimedia. Authors are K. Prajwal and Rudra Mukhopadhyay, C.V. Jawahar from IIT Hyderabad, and Vinay from University of Birmingham. So you can access it from this link. I read it in the description. So today we are going to discuss about abstract introduction, the related work, problem with the existing techniques, the architecture steps and limitations, uh, then we'll look into results and use case with our AI notes video tool. So starting with the first aspect, let's look into what abstract speaks about. So in the abstract, they have investigated the problem of lip sync expert talking face video as an arbitrary identity video matched to target speech segment. So, in overall, what they talked about is their current work excelled at producing accurate lip movement on static image. So, currently we have sync wave to lip and other application that did this already, creating a static image and picking it up like the lips movement are added on. I've added another video before on this. You can look into that. And they have identified the issues that images of videos of specific people have failed while they are doing training. It shows good results, but while in testing period, it's not going on good. So they have also proposed a new evaluation benchmark and metrics so to accurately measure the lip synchronization. If you want to access the code is available in this link. Uh, and K.R. Prajwal from IIT Hyderabad has gone ahead with building a new company based on this Sync Labs, in which they provide all the functionality which this research paper talks about. It's been too much time while this technology existed, and now they have created it and so for all. So you can access it this technology also, like an API for real-time lip sync. You can uh, register here for free. They have provided a video uh, where they provide in Hindi like how it speaks up this way. So you can access that. So now let's dive into introduction. So in introduction, they have provided that exponential rise in consumption of audiovisual content and rapid video creation has become quintessential need. So with the exponential rise in the consumption of audiovisual content, it's been a really important need, and creating this content in multiple different language is really difficult. So inspired from ObamaNet, photorealistic lip sync from text, and neural voice puppetry, which we talked about before, uh, these are the inspiration for this research paper, and based on this, they have improved things and found out some limitations and things like that, which we'll discuss next. So through this, they have led to creation of a speaker independent model where we don't need any speaker, but we just need a real sample like an image or a person talking something. Then you can create them, speak anything you want. So these models uh, were created based on different morphing techniques. They have added some kind of cut and paste of different uh, scenes of video. Like if a person is speaking some word, the cut and paste would be done to make them speak another word. So like that morphing is used, but these models are not accurate enough. We can easily detect that there is little bit difference or a much difference in reality and how the lip sync expert is doing. So they have also uh, collected the data, the recent data visualization in the data set. You can look into this link, and then you will see the visualization data they have collected, having lot of moving images talking up, through which they are using it. And then also they have created interactive demo. So in order to access this demo, let me show. So this is the demo where you can upload any file, video file and audio file, and then sync this pair. So I'll show the demo ahead. I've created already because it takes some time. But maximum it says up to 20 seconds compute latency, and it is really fast as compared to what it does. I have provided a collab link. You can access it from there to if you want to run. And this is an example video. David Sachs shows how AI is doing something in Hindi. See now, he's speaking in English, but how easily it's been turned into Hindi, and his lip movement were accurately right. So related work, we have talked about neural voice puppetry, which tried to minimize this data overhead. So they took two-stage approach. First, they learn speaker independent feature, uh, where they are presenting mapping with 5 minutes of data of desired speaker, but they train their speaker independent on significantly small corpus. So data set was really small for them, and because of that, cleaning of data and target speaker for generate was not good enough. Also, there are other related work like DRID, TIMIT, LRW, which are hampers of a model from vast diversity of mapping. So they have mentioned all this, uh, working on 1,000 words and limited by identities or vocabulary, like they can't speak in multilingual approach, which is the need of now. So these were problems with existing technique, like they are doing pixel level reconstruction, and there is no correct metrics to how we can check it. Like once it develop, we can also see there is a difference in what a real person speaking up and what's the difference in editing one. But in LibCan, they provided that there is only 56% accuracy of all other techniques, and they have provided a new technique, the LRS2 test, and they propose to use a pretend lips expert discriminator. A discriminator is something which provides you solution related to what's in the discrimination. So they propose the training model, a modified version of SyncNet and existing discriminator. They combined SyncNet and there was an existing discriminator and created a better discriminator, which take input window of V, and total of VTV, construct face frames on lower half only, like on the lips part, and then speech segment of size S, where TV and T are the audio and output time system respectively. So we'll look into problems with existing techniques. So editing such pre-recorded video is challenging, but can be needed to emphasize particular content like removing filter words, correct mistakes. More generally, using current video editing tools like we are using Adobe Premiere, skills editors, typically things like that are required. So we need this kind of uh, application that can provide all these issues and solve it all. So in this, they have provided the formula what they have used to calculate the ReLU activated video and speech embedding. So we are using dot product between ReLU, where embedding VS is a single value between 0 to 1 for each sample that indicates probably that input video pairs in sync, like P sync is equal to V as the embeddings and maximum of mod of V2 and S2 square and the constant. So to train their lip sync discriminator LS2, uh, they have split LS2 train into 20 approximately 29 hours with a batch size of 64. So 64 into about divide by 29 hours. So they received total V frame of 5 uh, and they are using Adam optimizer. So using this, they have get the initial learning rate of 1e minus 3, that is 10 to the power 10 7 minus 3. So the results are the expert lip discriminator is about 91% accurate on LRS2, while discriminator used in LibGAN is only 56%. So if they compared it with the previous one, their output is more better, 91%, but the discriminator they used is their own discriminator. So let's look into the image they have provided so we can understand how the architecture is correctly. So in the spectrum management, well, spectrogram segment, they provide the series of images like a video, and the ground truth segment will discriminate lower half, like on the only the lips part is would be discriminated, and the reconstruction is tested up. Then the pre-trained lip sync expert looks into this and discriminate. Now binary cost entropy is checked over here. If correct, then y equal to 1 or y equal to 0 if not correct. So this is the architecture which I talked about. Now the generator, in simple words, if I want to explain what it's written over here, the generator G is like machine that create video frame. Like here is a machine which create video frame. Then there is an identity decoder which decode uh, the identity like starting point, ending point, the layers which we want, like cutting off the face part only. There is a speech encoder. This part listen to the audio, like it looked into what the person is speaking. It use layers to understand sounds and turn into formats that our generator can use. Then there is a face decoder, which decodes who face, what the face is showing, the expressions and all this. So these together create video frame. Then discriminator checks the frame to see if the lips move realistically. Then discriminator says that lips don't look real, so that's a y is equal to 0 binary cross entropy. And if it works, then y equal to 1. So in technical steps, there is a temporal window. As I said, they have divided into 29, approximately 29 hours into 64 of batch size. So the temporal window of 5 frames, uh, and discriminator is at 5 frames of judging, then generating frames at time tries to keep the face features. So there is some input space where they are providing understand each frame in detail to live more realistically. So the overall goal is not to create something because it already exists. The overall goal is to create things realistic looking. So editors intent is using current video editor tool. One must carefully look into desired story like overall audio visual flow. So the key limitation identified are that the strong lips discriminator to ensure accurate lip movement. There is chance of slight blurriness, and there is chance of generating blurriness in photorealistic face in the video. The current method use reference frame during evaluation. The evaluation was not really good. They created their own discriminator. That's what's the need of creating your own discriminator and comparing. But it improved like compared with realistic improvement. The temporal consistency, the frames which are taken up are natural looking animation, like they are tend to be speaking, and there is some lack of specific metrics like SSI and PSR not focused on fine-grained lip sync accuracy. So benchmark and metrics, we look into that, how the model performed and how they are comparing with their own. So in the benchmark, you can see that there is LRW, LRS2 that they created, and LRS3. So in speech to width, which we talked about before, there is 13.4 accuracy. In LRS3 error distance, uh, in correct confidence, it's 1.762. LRS3 distance, error distance is lower is finer, so it's 13.14, while LibCan is 10.05, or real low, and wave to lib which they use is 6.512 minimum. And adding with GAN, generative adversarial network, it came around 6.74. So it was approximately same, but their own without GAN also worked better. Now we see confidence. Confidence is also high in this as compared to all. Then we look into FID score. It's also lower the better. So the FID score also, the GAN is leading up. Similarly in LS2 and LRST, we see their model is always leading up. So as compared to real videos, it's really less distance, like 6.512, and real videos is 7. In here also 6. So the proposed matrix that they use is, as we discussed, the SyncNet, which was existing technology. They used that, and on over that they use this lim to sync expert, and error distance and error confidence is used in order to compare. So in result, they compared approach with different models. Uh, the report that approach significantly outperforms previous model particularly. So in this, they have provided that how they beat their alternatives. Uh, so they have maintained good quality of speak lip sync accuracy across diverse video paths while fine tuned. And there was a little accuracy improvement without fine tuning. So in this, they have involved metrics like LACD, LS, error code, and confidence. So in human evaluation, they also involved humans who checked out the score views based on sync accuracy. Now we'll look into the conclusion. So the application of Wave to Live is in video translation. Wave to Live can accurately lip sync diverse video and dubbed into that. It can correct lip sync discrepancy, live translated press conferences, animation, gaming, and we can create demo videos like person speaking. We saw uh, in the lip sync uh, expert their own web application, lip sync labs that has been created. So by leveraging this, we can introduce novel evaluation benchmarks to create educational videos, cinematic dubbing, live translation. Like in this video, they are creating it. Now, if you see, you are able to see that the accuracy is pretty less. I think it's still not be able to do it. So that's the limitation what we discussed. Like this paper has talked so much about providing their own metrics, how they compared with others, but it's still showing that realistically it is not that much accurate. Now see, so they are selling their technology as a product also, providing the cloud over the service which they provide. this to create a video, translation and all this. So now in Collegiate AI text to video tool, we are creating the AI text to video, and as I discussed in uh, lip wave to lip sync expert, we need to create uh, a speaking person, like some teacher is speaking up, so they can add their video or photo, and then it looks like a person is teaching up here, so it look realistic more. Currently at our page, our website, on YouTube channel also, we can see only some amount of the result is looking like a PPT generated video. Like if I look into this class 7th video recently uploaded by someone, so we can see. So in here, if the person is speaking up a video like presentation is looking up, it would make it more better. So that's all. Thank you everyone.